Hi, everyone. Thanks for joining us. Today, our respective panelists will be discussing the unified application networking platform that is Greymatter and how application networking is the next evolution in enterprise connectivity. My name is Taylor, and I'm the digital marketing specialist at Greymatter.io, and I will be the moderator during today's discussion. I am joined by Howard Holton, CTO of Gigaom, and Jonathan Holmes, CTO of Greymatter.io. Howard, can you please take a moment to introduce yourself for us?
Sure. So I'm Howard Holton, the CTO at Gigaom. Gigaom's an analyst organization. I've been there about a year and a half. Before that, I was the CIO and CISO for a large manufacturing company. Before that, CTO Hitachi Vantara. Before that, I was the CIO for a legal services company. I go back 18 years in the CIO seat, 35 years in engineering overall. I wrote and sold my first piece of commercial software to law offices when I was 11 and have been in IT ever since.
Awesome. Thanks, Howard. And John, can you please do the same for us?
Yeah, absolutely. I'm Jonathan Holmes, CTO at Greymatter.io. I actually have been working in the application networking space, or really the microservices world, for quite some time, ever since really the Netflix and Twitter open sourced their overall products around that. Before then, I actually worked for a company that was more of an ERP type system, where they were building out similar to what Amazon is today. However, in those days, Amazon didn't exist. So it's been quite the adventure these days. And right now I've been working very closely with a lot of our customers in terms of how to actually envision the use of application networking platforms like Greymatter or utilizing microservice-based architectures.
Awesome. Thank you both. Greymatter is an application networking platform designed to simplify and secure connectivity for your hybrid and multi-cloud applications, APIs, and services, and provide actionable insights, all out of the box. In today's world, organizations are increasingly reliant on distributed applications. While this approach can enable a wide array of new capabilities and features, it can be difficult to manage, secure, and gain insights into how they are performing. Greymatter solves these problems. Our platform delivers streamlined application networking to connect your applications, services, and data across your different environments. Greymatter simplifies configuration management, enhancing developer efficiency while handling the minutiae of network and security plumbing under the covers. Greymatter's Zero Trust model helps enable cybersecurity mesh architecture, consolidating your security policies and enforcing them across your entire application network. Finally, Greymatter enables data-driven decision-making, providing you with insights like application performance, user actions, and resource consumption, which can help you to make better business decisions. So who are the biggest and most important vendors in the service mesh market? Let's take a look. Howard, can you please expand on what we're viewing here?
Sure. So this is the Gigaom radar for service mesh. Gigaom radar is just like any other radar, right? The ideal target is straight to the center. One of the important things to understand about Gigaom is we're an engineering organization, and so all of my analysts are engineers as well, just like I'm come from an engineering background. Engineers like nuance, and so when looking at kind of some of the things that our competitors did before we entered the market, we said, hey, there's not a lot of nuance contained here. It's kind of a light switch. You're kind of in or out, and that doesn't really fit for all of our organizations. When we looked at organizations, what we said was we generally buy on a scale of feature play versus platform play, and maturity versus innovation, right? Where we expect kind of new markets and new competitors to a space that have something valuable and important to say to be on the innovation side, and those that are kind of known and are kind of legacy entrants to a space to be more on the maturity side. And that allows customers to really determine what it is that they want, where they're shopping, where they want to buy, and kind of pick their quadrant. And then within the quadrant, right, the closer to the center you are, the better you are. And then we have kind of light blue, which is moving slow, dark blue, which is moving kind of pace of market, and then orange or on fire, that's moving faster than market, right? And so you can see here, Greymatter is in the both innovation and platform play space, right, which is right where I'd want to buy service mesh, closest to the center, and also moving at a pace that's faster than market. So we expect Greymatter to continue to be a leader and outperformer in the years that kind of follow, but it's a great position for you guys to be in. You should be very proud of it.
Yeah, definitely, Howard. I certainly believe that and we're going to discuss this a little more as we go through this, but as we start looking at some of the where we're going and some of the places where we've tackled really around making things easier is really critical.
Yeah, I would agree with that, right? I think we're going to get into some things that really dig into why we feel that you're on the innovation side versus just a little bit more than a service mesh player, or a little different than just a solid service mesh player. And I think it's important for us to dig into those things and customers to understand kind of the evolution of the space.
Awesome. Well, thank you both. Let's transition here and start talking a little bit about enterprise microservices adoption and maturity. My first question is for you, Howard. What are some of the drivers leading the enterprise to microservices, service-based architecture, and service mesh?
Sure. So a modern business really has has a focus on a few things. The first is making their business agile, and part of that agility is being able to react to kind of the constantly changing demands of customers, how customers buy, how customers consume. Legacy monoliths don't really allow you to be agile. If your customers change and thus your application changes, you're kind of rewriting this huge stack when it may affect where your customers are buying from, right? It may affect how your transactions are processed, right? So there's no point in having to rewrite an entire monolith. And microservices architecture allows you instead to kind of break those down into pieces and parts and use the pieces and parts that are best for your organization, for that application at that place and time, and give you the agility to really kind of manage what that stack looks like for you. Now, the challenge that comes along with that is complexity. Managing a monolith is something that that we've done for 50 years, and thus is incredibly well understood. And I don't really have to think about how the pieces interconnect to the level that I do when I start looking at microservices, right? Microservices is everything runs as its own service. Everything is effectively a micro server, and thus the data exchange components, the network components, the way all of those things interconnect and exchange data is far more complex. And this can lead organizations down the path of fragility. You can actually have the opposite of scalability because of that fragility and that complexity. And so you really get into kind of white space issues would be the best way to explain it, right? Sure, I can turn up Docker, I can put a database on it, I can put a web front end on it, and I have an application. But if I want to scale that application, there's a whole bunch of pieces missing. And if I don't have the maturity in the organization and I don't really understand what those pieces are that are missing, which we're going to get into here in a minute, then I can find myself in trouble, right?
Interesting. And let's talk a little bit about the service mesh itself. Historically, the market space was dominated by hype surrounding an application networking component called the service mesh. Howard, can you provide a little bit of background on the service mesh, telling us what it is and the opportunities it provides?
Sure. So the service mesh is exactly what we're talking about when we say you can get into trouble, right? Because yes, I can run Docker, I can run Postgres, I can run an Apache front end. You can do all that in containers, and all of those things can communicate. And that probably works great in my dev environment, in my lab environment. But as soon as I want to scale, and I need that to be 1,000 applications, and I need that to be 10,000 microservices, and I need it to be global, I need a way for those things to communicate in a way that is clear, consistent, reliable, and manageable. And that's where things like service mesh really, really kind of enter the picture, right? The service mesh is a way to consistently address the infrastructure components, not the hardware, but the base components that make up my container microservices environment. Service mesh is a very broad concept as well. And so you're not reducing complexity by dealing with that, right? And DevOps teams really are developers first and operations second. And so while service mesh fixed some things very early on, we also entered into the additional complexity. It was another layer of fragility. It was another layer of management. It was another layer of configuration. And so while it's a necessary feature, when you're looking at service mesh and kind of what to do with service mesh and what your service mesh needs to become, you really need to think about what is my organization, what is my organization desiring to do, what is the level of application development that we're doing, how are we going to scale these things, who's going to own them, who's going to manage them, and what's the kind of architecture need to look like in making those decisions. And you kind of keyed in on a key point, and that is for 40 years, application teams took the network for granted. and early attempts to micromanage the network, right? With application level segmentation, again, we're a level of complexity that nobody really wanted to manage. I don't know if anybody remembers kind of early VMware NSX attempts, but it went poorly.
I definitely remember those days.
Right, those days were a little rough, but what we have found, especially as we move into the cloud and deploy these apps as cloud native applications, the network is the application, right? The network is the security layer. The network is everything, and so you really need to focus on that network layer a whole lot more than you even do the API layer or the services layer, because that's where your biggest kind of low-hanging fruit is in improving performance, improving reliability, and improving stability.
Awesome. Thanks for that response, Howard. And John, can you discuss the path companies typically take when they decide to move from the monolith to microservices to service mesh and ultimately application networking?
Yeah, absolutely. I want to touch on one thing that Howard mentioned earlier is, from these capabilities that are operationally running as monoliths, a lot of times what we're seeing is these companies, they're looking to be more agile, right? They're trying to understand, how do I deploy my capabilities faster rather than dealing with this hairball of application code every time I want to make a change. And what we've seen in companies actually moving in this direction is, a lot of times, we all know Kubernetes is being widely adopted at this point. And when we think about service meshes, typically they start off maybe with one or two type services, and they're playing around with, it's software like open source software like Istio's control plane. Sometimes they're using Envoy natively to the actual environment itself. And these individuals are trying to piece together this more comprehensive system to help drive that agility. But as we all know, the complexity aspects do come into play when you start doing this. A lot of times, as that moves and you start getting more services, the overall architectural teams start getting involved. And they start looking at, how do they start to stitch all these pieces together to make a more comprehensive and more usable system. As it grows organically and you have more and more services operationally running, we have business teams that are starting to ask pretty difficult questions. And those questions are less about how the software operates and more around, how do you govern it? How do you gain more business insight and understanding around what's operationally running across my environments? How do I provide more fleet-wide control, or ensure that my security that you tell me is actually being put in place is actually being honored and implemented as it should be? And then really that visibility component across when you're more at the enterprise level, when you're operationally running in multiple cloud providers, or you have 20 plus Kubernetes services or servers or instances running, how do you gain visibility into the workloads occurring across those environments? How do you know when things are operationally experiencing issues? And that's really where the application networking platform starts to play, right? It jumps in and it provides that overarching cataloging of information, providing that insight and awareness, so that, and ultimately making it easier to bring applications online.
Great insights, John. And what are some of the challenges the enterprise faces with service mesh adoption, and where does it fall short?
Well, I think we hit pretty hard. Howard hit it earlier. The biggest challenge when we start thinking about service mesh adoption is really the complexity associated with it. And that complexity really gets exponential when you start thinking about more and more services coming online. You end up with configuration sprawl in many cases, where you have configuration files spread out throughout your environment. And really those configuration files, sometimes you have, for a single service, 10 or more configuration files, trying to understand the egress, the ingress, the overall routing rules, and everything associated with connecting that service to the other pieces on the network. That is probably one of the largest challenges. I will say, based on that, and what we have seen is there's also, a skill gap associated with what's required to operationally run this type of environment. How do you maintain it? How do you ensure that it stays stable as you push a service mesh into a production system? So those are I'll just mention those two around the challenges.
Yeah, and I think we find those two tend to twin, right? When you take the skills gap and the kind of lack of the ability to buy maturity, you have to build maturity, and then you combine that with the insane config sprawl, right? You end up creating this kind of twin, this twin occasion where one kind of feeds the problem of the other, and it starts to spiral and snowball out of control, right? And so I think that's where we get things like GitOps, which is really kind of taking control of managing that configuration and focusing on the configuration challenge rather than the tinker toys that keep it working. That we find that the configuration and kind of maturity and resilience around managing those things become key factors in success.
Yeah, no, I'll tell you what, the GitOps piece is absolutely critical. We'll get to it a little later, but we've incorporated and embraced GitOps solely to be able to reduce that configuration and automate as much as possible.
Awesome. Thank you both for that response. And John, how has the open source impacted the way the service mesh is perceived?
So, I mean, I personally love open source. I think it's actually a very good thing. It acts as an educational force to be able to bring newer markets up to speed on technologies like service mesh. And specific, when we start thinking of, what it did for service mesh, I mean, I think a lot of people really embraced it and they rushed to actually use it. I think in part of that rush created a tremendous amount of difficulty when they actually tried to go through and implement it or actually maintain it in a production system. And it really boils down to that configuration, right? The sprawl configuration. I'll also say that there are elements associated with lack of insight associated with what's operationally happening across the overall environment itself. A lot of, in this particular case, and specific to the service mesh market, many are actually Kubernetes dependent. And I think, and based on the customers that I've worked with, a lot of customers actually are more hybrid than we actually realize. They have multiple cloud providers. They actually have on-prem systems that they're trying to modernize and connect to their cloud providers. So that created even a bigger element around this. One thing I will say is, the whole entire premise around this, and when you think about how enterprises need this type of technology, because I really do believe they absolutely need something of the application networking space. And the reason why they need it, and while they may have embraced capabilities like Istio early on, they're now looking for the ability of making things easier. They're now looking for the ability of automating their workloads from an overall, from the inception of the creation of the API all the way to the management of the network to connect that thing to another piece as well. So that's really where things are going. And the open source honestly started that trend. And it really started from a networking perspective, but it's growing significantly after that.
Yeah, it's interesting. I find open source is where pioneering occurs, right? We discover and we pioneer in open source. And if you live and breathe, open source works great. When it comes to expanding and scaling to a large organization or to a large team, not everyone can live and breathe in the open source world. And that's kind of where the professional tools come in. Not that open source is inherently not professional, but it tends to require a level of kind of deep dive that we don't always have to give team-wide in an organization.
Yeah, I agree. And another thing that we also see is, a lot of people that have adopted these open source technologies, when you look at the entire stack, it actually gets fairly large. And these enterprises and businesses, it kind of goes outside their primary business focus. And they're trying to pull it back so that they can start focusing more on what makes them money, vice focusing on the plumbing associated with connecting these things together.
Yeah, I agree completely.
So given the challenges that you both identified, it makes sense that the service mesh alone is not enough to address the needs of today's enterprise. We earlier presented the idea of application networking, but John, can you tell us what it is?
Yeah, absolutely. We at Greymatter really view application networking as the backbone of modern application delivery. It really defines the interconnections between services, APIs, and applications as they get deployed into your environment. Ultimately, they're designed to provide a comprehensive suite of tools to optimize your application's performance and really unleash its full potential when it's out there. Being able to provide resiliency and scalability and agility really is critical to what they provide. And I'll kind of break it down into four different areas. When you think about, everybody wants their applications to perform better, right? And application networking platforms, because inherent to them, there's that service connectivity layer. They're designed to help streamline traffic routing, provide load balancing, which ultimately creates faster response times. Scalability is another core element to when you think about an application networking platform. As Howard mentioned, the network is critical, and the applications are riding closer and closer to the network these days. And your application needs to grow. Or as your application actually grows, your infrastructure around it should grow as well. And these application networking platforms provide that connectivity to all those capabilities that are expanding and retracting. Additionally, security. I recently read a statistic that 70% of applications have at least one security vulnerability. You think about that. It's pretty scary, and based on some of the overall data breaches that are occurring, you can understand that around that statistic and how impactful it can be. And what these application networking platforms are being designed to do is mitigate those risks, but mitigate it in a way that makes it very transparent to the application or engineering teams, so that when you do have an update, you can push that update to deal with various compliancy issues and not even impact the overall DevOps or application owners, the guys that are building the software. And then finally, cost savings. Everybody needs, and especially in today's day, we all are looking, how can we save on our bottom line? And really, application networking platforms are being designed to achieve that. And it's being designed based on all the automation that's being put in place, the adherence of GitOps, the ability of managing your entire fleet through a single configuration file. Simplification is always the winner in the end of the day. So those are really some of the four primitives that go into what an application networking platform provides.
Thanks for that, John. And what are the platform's principal elements?
Well, when we start thinking, down to the principles, connectivity across the network components is critical. This is inclusive of how these APIs and services actually interconnect. And it doesn't just stop at REST. And I want to make sure that that's clearly understood. Application networking platforms are really being designed to manage a variety of different protocols, a variety of different types of interfaces, all the way down to even data streaming services or connecting something to a database. Within that element, a service mesh does play. It is one of the principles of being inside of an overall application networking platform. The service mesh provides that connectivity layer to where it understands the network and it understands how to actually connect service A to service B and provide more features like traffic shaping or circuit breaking. Another primitive or principle would really be control. And control, when you think about a service mesh, control is very much what we would consider the control plane. You're basically feeding it information and it's feeding that information out, but it goes beyond that. Especially when you start thinking about how do you incorporate GitOps and how do you centralize configuration and make it easier. Then you start thinking that, that control isn't just necessarily some sort of API, but there is a central configuration management aspect to this that's defining your application networking as code that can be version controlled and everything of the sort. And then finally, really, you start thinking about how do I gain more insight into this? How do I ensure that the security that I'm putting in place is actually being adhered to? And, one of the things that's extremely important is hybrid compute, and being able to present a single pane of glass view across these cloud providers or across these multiple Kubernetes cluster is critical. To be quite honest, it's actually a pretty big gap that we've experienced in the overall environment itself as we work through our customers. They're predominantly, they don't even have the ability to see what's operationally running, let alone manage it, right? So those really do play into some of the primitives around how you would construct an application networking platform.
Great. Thanks for those insights, John. Can you now answer the big question for us? Why does all of this even matter?
Yeah, absolutely. I mean, when you think about application networking platforms, they play a central role in ensuring that modern applications can communicate effectively, securely, and reliably across all the environments that they need to. This can be on virtual machines. This can actually be across the CSPs and across Kubernetes environments. They contain features like the ability to control, secure, and gain insight into your infrastructure needs. These are all vital for delivering high-performing applications. They're also seamlessly enabled when you think hybrid and multi-cloud communicate, or they seamlessly enabled hybrid and multi-cloud communications, and are used in many cases to start driving those costs down through automation. And at the end of the day, when we start looking at why the application networking platforms are extremely important, it's really to make our lives easier. If you recall, the biggest challenge we have is these types of environments, and when dealing with specifically when dealing with a service mesh, it's extremely complex, and that complexity ranges. I'll just bring up one example. Managing something like certificates can be extremely difficult, especially when you're actually issuing cryptographic certificates per workload coming online. And in many cases, sometimes they don't even do it, which is unfortunate. But today we have the technology to be able to actually manage that, and not only manage it, automate the entire process to where every workload coming online is being attested that it even should be online. Every workload online is being verified that this thing on the network is able to communicate to this other thing on the network. And that's all cryptographically enforced. And those certificates are rotating, let's say on an hourly basis. Whereas before, if you were using certificates, maybe you would just issue one certificate that was being used for a particular application for a year, let's say. And then you come down to the conundrum, you have to remember that you even did that. Otherwise, you run into the scenario where things start going offline. And that's not what we want.
No, they never go offline during the most appealing time for them to go offline, right?
No, they never do.
They always go offline when you're at a barbecue with the family, relaxing, right?
Absolutely.
Go
I've
off
been in
the-
that
you
situation many
never,
times.
of course, and you never immediately go, oh crap, I forgot to renew that certificate. You always go, ooh, I have no idea what happened. Let's go try to figure it out.
Right. And this is why I love the features, because, you know, I have been in those situations before the technology was there, and now it's here, and it really can be automated to where you don't have to worry about it.
Well, it also becomes part of your zero trust framework, right? And your zero trust deployment. If I'm using certificates to attest that this is the right application, that this application is authorized, right? And I'm doing proper certificate rotation, then that becomes yet another layer of security that allows me to control that trust with even a finer tooth comb than I otherwise can, and starts to become really, really important and really valuable.
Absolutely. And one of the things that we take very, very serious from a Greymatter perspective is security. Uh, it's not just the MTLS. It's also incorporating features like identity aware networking and understanding who's doing what, where, when, and how. And that's so critical because, you know, in the past, we've always talked about DevSecOps, and traditionally DevSecOps has always been what do I do in my pipeline before my code gets deployed, right? But now what we're looking at is, okay, now my code's deployed. How do I ensure everything that just got deployed is actually operating as I intended to operate and as secure as possible? And that's what typically people refer to more day two operations. And really, we play a massive role in that because of our ability of understanding the intelligence and the connectivity tissue between these things and how they're actually communicating across the wire.
That makes sense, right? I always say if you're doing DevOps, you're still doing DevSecOps. You're just giving sec the null value.
Yep.
Great. Well, thank you both for that. And so based on our conversation so far, it seems like complexity is a common theme throughout. And earlier, you both talked a little bit about the complexity challenge. But John, can you expand on that a bit more in the role Greymatter plays in complexity management?
Yeah, absolutely. You know, we embraced it wholeheartedly. We realized up front that the overall implementation or how things were being implemented was becoming more and more complex to the point where you have this pivotal moment where you reach critical mass and you start thinking, can I actually manage all this? And in many cases, sometimes you can't, depending on the technologies that are in place. And what we've done at Greymatter, and as I mentioned, is we fully embraced GitOps. And with that, though, we've also created a new configuration specification called the Greymatter specification language. It is based on QLang, and that allows us to provide over 100 out-of-the-box configuration abstractions. What used to take you 1,000 or 3,000 lines of YAML code, we condensed down into essentially a couple lines of code. And we actually automate most of it. So, and through that automation and generation of that code or configuration under the covers, you can easily take advantage of connecting these things together and ensuring that the things like health heuristics are enabled for all your services, ensuring that full mutual authentication is enabled for your services, ensuring that when you're dealing with this concept of identity-aware networking, that the identities are propagating through your network with only a couple lines of code, right? Or a couple lines of configuration that lives in this Git repo. And then that essentially can really be broadcasted to all your instances that you're operationally running. So that you're managing a single source. It's very small in comparison to what it used to be. And it's being validated, verified before it actually gets pushed into your infrastructure. And that's a really important point. I can't tell you how many times people maybe fat-fingered a configuration file, it's made its way into the actual system and the system went offline. And with the Greymatter specification and how we've actually reduced the complexity, part of that is also reducing human error, right? And being able to make it easier for them to manage their system. And ultimately, you know, everybody needs to understand and gain clear insight into what's happening. So we've done an extensive amount of work to be able to do those types of features.
Thanks, John. A lot of great information so far. And Howard, let's lean into your expertise here. The service connectivity layer has risen as an important development in service-to-service connectivity. Can you tell us what the SCL is and some of the components, and how prevalent has the term been in the market thus far?
Sure. So we're not seeing I haven't seen the SCL featured nearly as much as service mesh. I think it's still a relatively new term, but if we look at what the SCL is, the goal of the SCL is to catalog and make available, and in some ways advertise, the services that are available to developers to leverage within an organization or within an application even, right? If we go back to kind of everything is becoming an API, which I think we've heard over and over for the last 5 years, the SCL really is kind of the ultimate extension of that. You could kind of think of it as the waterline that really should have existed since DevOps first was created, but we really didn't. Well, we didn't know what we were doing. We knew DevOps had to exist, but we didn't really have a full tool stack. And what we really need is we need developers to be developers and IT operations to be IT operations, and the attempt to kind of cram those two things together created DevOps. It's very useful. It works. However, developers are really good at software development, and infrastructure people are really good at infrastructure. And what SCL really allows you to do is kind of lean into that, right? And create a waterline that says everything above this waterline is designed for developers, and everything below this waterline is really designed for operations to manage, and really helps speed up both sides of the coin, both processes, right? And creates better cohesion between those two disciplines within the same organization, within the same kind of business unit. So as we start to see SCL take off and become adopted in a way that is effective and has that maturity and removes the fragility, we're going to see great kind of enhancements in what DevOps becomes. I almost think DevOps is going to go away as a term in the next decade, because it'll end up being kind of what we intended from the beginning. But SCL is a further kind of evolution of that.
Awesome. Thanks for that, Howard. And John, what are some of the drivers behind SCL adoption, and how can a platform like Greymatter address them?
So we got to remember where we started. Microservices architectures really have revolutionized application development and deployment. Smaller services offers a lot of scalability, but the overall challenge here is they still rely on that network, and they still rely on seamless communications to achieve what they're looking to achieve, actually. When looking to implement really distributed systems, features like scalability or fault tolerance really aren't optional add-ons. Even gaining insights into what's operationally running is not an add-on as well. They are becoming more of the cornerstone to ensure that the systems stay operational and really are successful. This is where really a robust service connectivity layer like Greymatter plays a very critical role. Greymatter provides those automation tools that I mentioned earlier, really needed to navigate these challenges seamlessly. This is done really by optimizing how these microservices and applications interact, as well as being able to discover them, as Howard mentioned, and catalog them across the entire space. They are often designed to be able to provide, that whole service connectivity layer when you're thinking the routing or the dynamic routing and load balancing and failover. And all these features really result in a very efficient and effective communication strategy between the applications and the services that are underneath them. Another piece that is often overlooked, but very critical, is whenever you think a distributed system, failures do occur. We just have to realize that they're going to occur. They happen. But what we've done at Greymatter is we've ensured that we have the necessary resilience policies to be able to perform across these hybrid operations. And that really allows us to fail both local to the cluster or geographically fail. In fact, I'm working with a customer right now that allows us to more do that exact scenario where we're splitting the traffic between a local node. But if something occurs on the network, for some reason, the network starts to experience issues, we're able to actually go through and automatically start redirecting traffic without any interaction from an actual DevOps resource or anything of the sort. Now, on top of that, you have to be able to visualize the fact that that's occurring on your network. You know, being able to provide that visualization is also critical here. And dealing with those failure scenarios and just understanding failure is going to occur. It's just how do you react to it? It's almost that fail fast mentality is absolutely one of the major pieces around this.
Thanks, John. Additionally, it seems like interest in the platform engineering use case is gaining a lot of steam lately. Howard, can you discuss platform engineering a little more? Do these teams have buying power? And on that note, is an engineering platform something you could just buy off the shelf?
Sure. So platform engineering is kind of what it sounds like on the tin. It's in the same way DevOps is kind of what it sounds like, right? DevOps is that connectivity of development and operations together in a cohesive team. And a cohesive role, really, it's one role. Platform engineering really is the team that defines, builds, and manages the developer platform used within an organization. And why that's especially complicated is because the IDE that you use kind of in monolithic application design is incredibly different than what we think of as the IDE or the development environment in a microservices platform design, because in a monolithic, it's really just Visual Studio Code or whatever coding tool you're using. In platform engineering, and when we think about that platform and the IDE that's associated with it, it is everything from the container technology up. And it's up to that service control layer that we talked about before. And really defining what are those things, what are the standards, what are the best practices, what is the architectural kind of focus that we're going to have within the organization. And good platform engineering teams sit as a subset of enterprise architecture, because those two things kind of go hand in hand. Because of that, good platform engineering is highly bespoke to your organization, to what your business needs are across the entirety of the organization, how your teams work, how your business works, how your business operates, what your regulatory controls are, all factor into good platform engineering. And because of that, it tends to be bespoke, even in a brand new organization. It still tends to be bespoke to the organization. And so, no, you can't successfully buy platform engineering in a box, right? It requires an awful lot of thought and architecture and ownership to be successful, to truly be successful.
Yeah, I completely agree with that, Howard. And actually, what we're seeing as well is exactly what you said. These platform engineering teams are really appearing under that enterprise architecture organization unit. Because honestly, they need to understand so much associated with how things are interconnecting and work with both the engineering teams and then subsequently the infrastructure teams to ensure that what's being deployed is deployed correctly and operating correctly.
Awesome. Well, thank you both for those insights. And let's talk about the wider market for a moment. Howard, where do you see the market for application networking platforms like Greymatter?
Today it's, I'm not going to say it's small, but it's kind of, 2010, 2011, 2012, when we kind of were looking at containerization, right? When that first kind of came on the scene, we're past the point where it's restricted to bleeding edge organizations, and organizations are now talking about what does network management look like for the future? And I will say, I think more of it's being driven by cloud and some mistakes that were made in cloud rather than cloud native application or platforms, right? Enterprise platforms. But it's being pushed into enterprise platforms. Like if we're thinking about it for cloud, and cloud is built around cloud native application engineering, we also then need to think about it within our cloud native application stack and that engineering platform that we just talked about. And so we're seeing a massive uptick, right, in application platform networking. And I think that's going to continue until it simply becomes the network, right? And how we think about the network is within the context of this kind of culmination of disaggregation and microsegmentation and application platform networking kind of all come together into this one unified method of really managing network traffic. because kind of to Jonathan's point, right, we're pushing more and more and more to the application is the network and the network is the application. And we have to stop thinking about these things as though they're a known quantity, which was kind of, we've kind of just assumed the network will work. It's become far more complex, and it really is the core of performance. It's the core of security. It's the core of resiliency and reliability. It's the core of scalability. And so I think in the future, we're going to see these application performance or application platform networking tools simply increase in priority, increase in value, and increase in adoption within organizations.
Awesome. Thanks, Howard. Well, we've covered a lot of ground today, and obviously there's much more to discuss. But this last question is for you, Howard. What do you think application networking vendors need to do in order to stand out in the market? So
I think there's three things, and it's going to be sad because they're not specific to application networking. They're really specific to how smart executives buy. Right. The fact is, I buy trust. I don't really buy anything else. By the time you get to the actual buyer, right, the person that controls funds within an organization, you've likely gone through engineering, and engineering has said, yes, this works. Right. So the first thing is you need to do what you say on the tin. Right. You need to do the things that you say your product does to a reasonable level. Right. Nobody's perfect. It's kind of like a resume a little bit. You know what I mean? But the core fundamentals you need to be able to do, you need to be able to do well. So you need to do what you say. The second would be, I'm buying longevity in the company. Like I need to have faith that you're going to be around for a while. But most importantly, by a huge margin, I need to know that you have my back. Right? Especially if you have any competitors that are open source. I need to know that you're now part of my capability ecosystem. Right? So that when my people, right, we talked about kind of the skills gap, and we talked about maturity, and we talked about all these things, I'm buying some of that by engaging with in a commercial solution. And so I need to know that when things go wrong, that you're there for me, that you are effectively an extension of my team. Right. And so those are the things that I would really concentrate on. Don't say you do things that you don't really do. Like, be clear about it. Be good enough that I can have faith that you're going to stick around, right? It's a volatile market. We all know how that goes, right? But really, when the other two don't work, make sure you have my back. Right?
I think that's extremely important, Howard. The having my back is one of the biggest things that we here at Greymatter truly value. We realize, like I mentioned, things are going to happen, right? And you need to be able to have that reach back. You need to be able to have that support. And you need to be able to have the team be able to come in rapidly to be able to get whatever just occurred back online, and to ensure that lesson learns are created, right? So that it can be reincorporated back into the product or reincorporated back into the solution to ensure that the next time there's even more resiliency to failure scenarios.
Yeah, 100%, right? It's not about blame, it's about better. Right? Yeah. So what can we all do to just be better? I never, when something happens, I don't actually care who made it happen. What I care about is, do we know what happened? And can we put something in place to mitigate that issue in the future?
Yep.
Right?
Yep. I really think it boils down to a partnership that you form with your customers, and instilling the confidence that no matter what, we're always there.
100%. 100%.
Great. Well, thanks, Howard and John. This has been a really great discussion today. I'd like to thank you both for your time and all of your valuable insights and feedback. For those of you who are viewing this, thank you for watching, and please do not hesitate to reach out to John or myself at our respective emails shown here if you have any questions about Greymatter. Thank you.